Okay, hello. Let's look at some more examples. The cube root of x plus the square root of x won't simplify. There's nothing you can do. They're not the same type of root. The trouble is you've got a cube root here and a square root here. Okay. However, now if you can multiply these, you have to use the laws of exponents. Like the cube root of x times the square root of x, that's x to the 1/3 power times x to the 1/2 power, and you add 1/3 to 1/2 and you get 5/6 when you add the fractions. So you get x to the 5/6. But remember, in radical form, what the very definition of x to the 5/6 is the 6th root of x to the 5th power. Okay, so we could do that. Now, the square root of x plus the square root of y, that won't simplify on account of different variables. It's for a different reason. Same type of radical, but we got different letters. And neither will radical x plus radical 2x or something like radical x plus radical xy, so on and so forth. Now, it is true that you can write this in a different form or format like this, but that's not really combining terms. That's sort of beside the point. Okay, let's move on. Like the square root of xy squared. Guys, remember there's an understood index of 2 here, and for the y term, 2 divided by 2 is 1, so this comes out as y to the 1. After all, the square root of y squared is just y. If y is positive, and we are assuming that all variables are positive throughout this whole video, from beginning to end. So we got y times the square root of x, and now the square root of x squared y squared equals xy. Again, we're assuming all variables are positive. And the square root of x to the 24th y to the 28th is x to the 12th y to the 14th. Now here's a different one. The square root of xy cubed. That's going to be, well, how do we deal with that? You want to filter y squared out of it. So you get xy times y squared. Or you could say y squared times xy, either way, commutativity. But that y squared comes out as a y, and you get y times the square root of xy. So in other words, the square root of xy cubed and y times the square root of xy are the same thing. So if you subtract them, you'll get 0. And if you divide them, and as long as nobody is 0, you'll get 1. Now, if any, well, actually, we're assuming all terms are positive anyway, so we're fine. So yeah, we can divide them, and we'll get 1. Okay. So we're assuming everybody is positive, as always. Okay. Okay, now for this next one, 7 times the cube root of x plus 12 times the cube root of x. Now these are like terms. That's just 19 times the cube root of x. And then 7 times the cube root of 40x plus 12 times the cube root of 40x. That's 19 times the cube root of 40x. That's true, but your teacher, he or she will likely want you to simplify that. Notice that, is there a biggest, since we're doing the cube root, we want a perfect cube. Is there a perfect cube factor of 40? Yes, there is. And it's, it's 8, and I made a mistake. Sorry about that, guys. That 8 should be inside here. My bad. So 40x can be filtered as 8 times 5x, and the reason we wanted that 8 filtered was so that we could take it out, and this is wrong as well. What's going to happen, guys, is that 8 comes out of the cube root. It comes out as a 2. Okay, yeah, I messed that up badly, but it's good now. And then, so 19 times 2 is 38. So we got 38 times the cube root of 5x. And again, of course, the 5x cannot come out. You know, not even close. So there's that. So to recap, you bust 40x up into 8 times 5x. And you do, the 8 comes out as a 2, and 19 times 2 is 38, so you get 38 times the cube root of 5x, like that. And I'll save that word. That way it won't be botched up later, you know, when I open up the file. And I need to send you guys an updated file, if you did save the file or whatever. But anyway, moving on. Now here, I'm going to make one little all-important change. See this plus sign here? Notice this plus sign is a separator. It separates this term here from this second term right here. However, what if I make everything vague and turn that, what if I change everything? This is not going to be the same problem anymore. What if I change this plus sign to a times sign right here? That changes everything. I just multiply across. 7 times 12 is 84. Now the cube root of x times the cube root of x, that would be the cube root of x quantity squared, but remember from the laws, that's just the cube root of x squared. You can bring the cube root of x times the cube root of x, that's the cube root of x times x, which is the cube root of x squared. Okay, so there's that. And in a similar fashion, now I'm going to do all times in again, but what if I cause some trouble? What if I turn this cube root here into fifth root right here? So in this problem, I'm generalizing. So again, I multiply the 7 and 12 and get 84. But now here, if you don't have the same type and you're multiplying, you can still multiply things if they're not the same type. So you'll have x to the 1/5 power. You turn that fifth root of x into x to the 1/5 power. You turn the cube root of x right here into x to the 1/3 power. So you get 84 times x to the 1/5 times x to the 1/3. Now remember, by the laws of exponents, you add 1/5 to 1/3 and you get 8/15. So you have 84 raised to the power of 8/15. Excuse me. No. Yikes. Mistake. You have 84 times x. No, the 84 is not raised to any power except 1. You have 84 times x raised to the power of 8/15. My bad, guys. Sorry, I forgot my x there. I'll save that as well. So we got 84x. The only thing being raised to the power of 8/15 is just the x variable. So sorry about that. So we got 84x to the 8/15. But remember, if your teacher wants you to go, you can stop here if your teacher just wants exponent form. But if your teacher wants radical form, you'll need to write 84 times the 15th root of x to the 8th power, okay? So there's that. So, and that was an example I wanted to do. It didn't flow as nice as this other one. You could do this process for this guy up here, but it'd be silly. But anyway, if I'd have done this up here, we'd have had 1/3, 1/3, which has been 2/3, and it would have been this guy right here. But anyway, now let's go down here. Let's look at this guy. 7 radical x plus 2x. That's not going to simplify because this is an x. This is a square root of x, so they're not like terms. They won't simplify. Now watch out. Watch this guy right here. Notice in this example, I'm playing sort of visual trickery. This is the square root of 3x. X is inside the radical house. But for this guy right here, x is not inside the house. Notice the house cuts off at the 3 here. Only this 3 is inside, not this x here. That won't simplify. However, if the x is inside for both terms here and here, then you'd get 2 rad 3x, because it'd be 1 rad plus 1 rad would equal 2 rad. Or by rad, I mean square root, of course. Okay. Note that 2 radical 3x is not radical 6x. In fact, if you were to bring this 2 back inside the square root, it would turn into a 4, and you'd get radical 12x, not radical 6x. Indeed, radical 2 times, you would need to, now if it was radical 2 times radical 3x like this, then you would get radical 6x, but that's not the same thing as just plain 2 times radical 3x. This is radical 2, this is just 2, okay? Indeed, if you bring 2 inside a radical, it turns into you square it, it'd turn into a 4, and you get radical 12x. If this 2 would have been a 5, let's say I had 5 radical 3x, it would come in as a 25. You'd have 25 times 3x, that'd be radical 75x, and so on and so forth, okay? So there's that. And if it would help, I'll type that out. Give me just a brief bit just to type this out. I'll make it fast. Oops. And so there's that, and there's that. And I'll put and. So here's that other example. The 5. If you bring a 5 inside a square root, you have to make it 25, because radical 5 is radical 25, or square root of 25. I mean. So, but anyway. So the 5 would come in as a 25, it'd hit that 3x and make 75x, okay? Now you may rightfully ask, now what about if I'd been a cube root, then 5 would have came inside as 125 because you'd had to cube 5. And if that would have been a 5 times the 4th root of 3x, then 5 would have came in as 625, and you'd had 625 times 3x, and you get 1,875x, and we're getting big at that point. And if that helps, I'll do that. And so let me just type a little note. So I'll put note, and let's type that in. So if I had like 5 times, and then the fourth root of, I'll just, since we're doing 3x, I'll just, it doesn't have to be 3x. It could be this, the idea works for just about anything. I'm just picking on 3x here. So what's going to happen is, since we're doing a fourth radical, that 5, yes, it can come inside, but you have to fourth power it. And 5 to the fourth power is 625. So you've got 625, and then you got to multiply by that original 3x. Now that 3x, it was already in there. And so you do 625 times 3x, and so that's going to be the fourth root of 8. You multiply, you do 625 times 3, you get 1875, and then times x. And there it is. And if it would have been, now the cube root would have just produced 125. The fourth root produced 625, so on and so forth, okay? So you get the idea, and I'll save that. So let's move on. Now, remember a minute ago we could not add these. It was non-simplified. Well, we can add them, but you can't simplify it. I mean, it's a legitimate, like 7 radical x plus 2x. It's not that it's an invalid process. You just can't write it in simpler form, okay? But now if we multiply it, we can write it in simpler form. So 7 radical x times 2x, you just multiply the 7 and the 2 and get the 14, and just stick the x on, and just stick the radical x on. And by the way, guys, if you wanted it in exponent form, if you wanted to go further in exponent form, you would have 14x to the 3 halves. Because what you would have is you'd have an x to the 1, you would have an x to the half, but your teacher's probably going to want you to clean that up. She's going to want you to write 14x to the 3 halves power. That's assuming that he or she wants exponent form at all. He or she might not even want that. They may just want you to leave it like this. It depends. In some situations you'll want this. In other situations you'll want this. They're the same answer, but they're in a different format, okay? And so there's that. Now, let's go down and look at some more examples, just to refresh. Square root of 3x plus the square root of 3x is 2 times the square root of 3x. Now, however, the square root of 3x times the square root of 3x is just plain 3x. We're assuming all variables are positive, as always. 2 times the square root of 3x times 2 times the square root of 3x. Here's what you do here. You multiply the 2 and the 2, and you get 4. If that would have been a 5 times 5, it would have been 25. But anyway, now you multiply radical 3x times radical 3x, and you just get plain 3x. But hey, 4 times 3x, by associativity, you can multiply that 4 and that 3, you just get 12x, okay? And let's look at this example down here. Now, 12 radical 3x minus 7 radical 3x, the radicals match. We're in good shape. We just subtract the 7 from the 12 and get 5 radical 3x. And by radical, I mean square root, okay? Now, what if we multiply these two? That's a little bit harder, but it's not hard. Just do 12 times 7 is 84, and radical 3x times radical 3x is just 3x itself. But by associativity, you can multiply that 84 and that 3, and that's 252. And times the x. Don't forget the x there. Okay. So there's that. Now be careful. 12, like if you what if I do 12x rad 3x plus 7 rad 3x? Notice the radical 3x's match. That's good. There's nothing wrong with the square roots. The trouble is this is a 12x, and this is a 7, so they won't simplify anymore, okay, because we're adding. Now, if we would have multiplied these, we would have had 84x radical 3x. And I'll copy that here. Notice multiplication is far more flexible than addition. An analogy can be made between division and subtraction as well. Division being the more flexible one. So if I would have did 12x and then radical 3x times 7 radical 3x, that would have been 84x radical 3x. And that's good. And you can, like that. Okay, just to show that off and show that I can do it. Okay, so there's that. Now let's go down here. 12x to the 6 times radical 3x times 7x to the 8 times radical 3x. Well, just multiply the 12 and the 7, you get 84. Multiply the x to the 6 and the x to the 8. Remember, by the laws of exponents, you add that 6 and 8 and you get 14. Multiply radical 3x and radical 3x, you get 3x itself. But then after that, you can do associativity, law of exponents and all that, commutativity. 84 times 3 is 252. X to the 14 times x to the 1, you just add 14 and 1, you get x to the 15 by the law of exponents. So you just get 252 x to the 15, where I multiplied the coefficients, and I multiplied x to the 14 times x to the 1, but that gives me x to the 15. You add the exponents when you do that, okay? So there's that. And that'll be all for this video. Thank you. I'll see you on the next video.